In 1976, a team of performance specialists set out to design the finest racing and street cams in the world. The same winning technology we developed for Bob Glidden, Darrell Waltrip, and Dale Earnhardt is designed into every cam and component we make. For information, call the Cam Help Tech line at 800-999-0853.
In 1976, a team of performance specialists set out to design the finest racing and street cams in the world. We did our homework in the 70s to accomplish our goal of domination in the 80s, both at the racetrack and on the street. Did we meet this goal of perfection? Why not ask a few of our test drivers? Top racers like Bob Glidden, Darrell Waltrip, and Dale Earnhardt spoke for the superior power and durability of our camshafts and valve trains. These winners can run any cam they want, but they choose to stake their reputations, as well as their livelihoods, on competition cams every time. There has to be a reason. That very same race-winning technology is engineered into every race and street cam we produce. As a matter of fact, our high-energy series and its more powerful counterpart, the Magnum, pioneered the use of race cam technology in performance street cams. One extremely crucial factor to your engine's horsepower and torque is the induction system and how well it works with your camshaft. And while both the manifold and carburetor play a major role in bringing the mixture into the combustion chamber, the camshaft is without doubt the brains behind this process. In fact, a camshaft can deliver the single greatest power increase possible to your engine. All camshafts are not created equal. Just because two cams share identical lift and duration figures does not mean that they will produce the same power. Not even an expert can tell these two cams apart without sophisticated computerized measuring equipment. But your engine can certainly tell the difference. Competition cams engineers in variables like lifter velocity, ramp angle, and valve acceleration to precisely determine the valve's motion. These subtle differences make as much as 15 horsepower difference in two so-called identical cams. So be careful when choosing your cam. Remember these three important points. Number one, make sure the company has a strong research and development program to ensure you the cutting-edge technology that will make your engine perform to its maximum potential. Number two, does the company have the racing credentials that prove its technology? If Glidden, Earnhardt, and Waltrip don't trust them, should you? And number three, you must have a wide range of cams to select from. If a supplier only has one or two basic cams, your chances of getting exactly the correct combination are slim. You're likely to end up with a compromise cam. At Competition Cams, we offer over 30 high-energy and Magnum grinds, plus any custom grind you need. Each cam is specifically engineered with regard not only to engine size, but also the transmission, converter, gear ratios, weight, and intended use. There is no compromise with Competition Cams. We know camshaft selection can be a very confusing process, so we've made it easy. Our new Cam Help toll-free tech line will assist you in the proper selection as well as the installation and degreeing of your cam. Remember, you're never more than a phone call away from Cam Help, 1-800-999-0853. So, let's start with a detailed look at the high-energy series of cams. All high-energy designs produce more power and better mileage than the stock cam, but they retain excellent drivability factors such as idle quality and vacuum for power accessories. Leading into our high-energy series is our 240. With maximum torque between 1,700 and 2,200 RPM, the 240 is a good choice for daily driven vehicles, computer-controlled cars, light trucks, and V6 engines. The 240 provides very smooth idle, quiet operation, and good throttle response. Plus, you can expect better gas mileage and a power increase over your stock cam. The 240 is a great replacement for OEM because no additional valve train components are needed. Our second high energy is the 252. Ideal for 305 to 350 cubic inch engines requiring good low-speed torque, the 252 is a good all-around cam for family sedans and light trucks, and it's a great performance cam for turbocharged V8s. This cam puts maximum torque in the 2,000 to 2,500 RPM range while providing a smooth idle and good vacuum, and works well with computer-controlled ignition systems and high gear ratios. And like the 240, the 252 requires no additional valve train components. Next up is our 260. The 260 performs well in pickups and four-wheel drives or medium-sized tow vehicles. This cam also provides excellent torque between 2,500 to 3,000 RPM in 350 to 400 cubic inch engines. A great match for anything from a motorhome to a dually, the 260 provides good vacuum and idle without interfering with your power accessories. The hottest cam in our high-energy series is the 268. The 268 finds maximum torque from 3,000 to 3,500 RPM. This is our best-selling cam in that it's ideal for muscle cars and daily driven street machines. The 268 provides a dramatic increase in torque and horsepower, but won't affect your power accessories and overall street ability. In smaller engines, this cam will provide a slightly racy idle, but in big blocks, the idle will remain smooth. The powerful Magnum cams are designed for the serious street enthusiast who is looking for maximum output with that pro street sound. Leading into the Magnums is the 270. Our newest cam, the 270, is engineered for anyone with a daily driven street machine. This cam offers a flat torque curve between 2,500 and 3,750 with peak horsepower at 5,500 RPM. Power accessories will not be affected, and the 270 works great with 9.0 compression. So, if you want the absolute maximum power while still keeping your stock converter, the 270 is your cam. Our most popular Magnum, the 280, is ideal for 350 to 400 cubic inch motors with 9.0 to 10.0 compression ratio. Providing excellent torque at 3,000 RPM and maximum horsepower at 6,000 RPM, the 280 is the largest cam to use in a daily driven street machine or muscle car. A real power maker, the 280 Magnum is guaranteed to make your day. Our 292 Magnum is our most powerful street strip cam. This cam has some nasty habits associated with race cams, so street use should be limited only to the most hardcore enthusiast. The 292 is used in 10.0 compression ratio engines with a stall speed torque converter and low gear ratios. With a power range from 3,000 to 6,250 RPM, this cam has a radical idle with a gutsy sound. The last cam in the Magnum group is the 305. A radical racing hydraulic cam with the power range starting at 3,500 RPM and peaking out at 6,500 RPM, the 305 is great for use in 10.0 plus compression ratio engines. This is a pro street cam and should only be used where streetability is not a major concern. It's very important to note that all Magnum cams must use Magnum valve springs. Improper springs may not have sufficient pressure to keep the lifter on the lobe. The wrong spring may stack and become solid at maximum valve lift and cause lobe failure. Small block Chevy owners will definitely want our new conical valve springs that fit stock spring pockets without expensive machining. This works great for all Magnum grinds up to .550 valve lift. When installing either a high-energy or Magnum cam, bear in mind that the timing chain set is critical to realizing the maximum potential of your powerful cam. Most stock and replacement timing gear sets retard cam timing and kill power. Only by using a Compcam's True Zero set can you be assured that your cam timing will not be retarded. One of our most popular products is not even a camshaft, but our patent-pending Magnum roller rockers. If an easy-to-install, low-cost additional 15 to 30 horsepower is what you're looking for, our Magnum roller rockers are made for you. Unlike stock rocker arms, Magnum roller rockers won't flex and have a ratio that's dead on. What does this mean to your engine? More net lift at the valve, resulting in all the torque and power your camshaft was meant to deliver. But hang on, power is great, but not if a rocker arm can't survive at higher spring pressures. At Competition Cams, we designed our Magnum roller rockers to take almost anything. We made the Magnum's body from 8620 chromoly steel, which is over twice as strong as stock rocker arms. And what about a roller tip? Non-rollers scrub the valve end and push the valve stem hard against the guide. This friction robs your engine of power and causes heavy wear to the valves and guides. With our roller tip, the Magnum rolls smoothly and effortlessly across the valve end. Sure, we're confident about the quality and performance improvements of Competition Cam's components, but so are the enthusiast magazines. Keeping track of Vets journalist Dennis Quitoni states, "I don't mean to sound like a salesman for anybody, but the Competition Cam's valve train parts are really better than stock and do help the motor produce more power." Mose Ludell reviews our Magnum roller rockers on a 350 Corvette in Corvette Fever magazine. Torque, the key to acceleration and off-the-line performance, had increased substantially with no other change than the rocker arms. The new engine generated big block sensations. We didn't say it, they did. But we couldn't agree more. So remember, with Competition Cams, your questions will never go unanswered. Competition Cam's all-new complete valve train reference catalog combines over 140 pages of technical tips, applications, and specialized sections on cam degreeing, valve timing, and practical answers to your questions about high-energy and Magnum camshafts. Available directly from Compcams for $5. The proper procedure to install and degree a camshaft is a 35-minute instructional video with all the know-how you'd expect from Competition Cams. If it's your first cam or 40th, you're sure to benefit from this detailed and professionally produced video. Whether you need a high-energy, Magnum, or race cam, do it right the first time. Call Cam Help, our new toll-free tech line, at 1-800-999-0853.
With over 20 years' experience in racing and high-performance engine building, Competition Cam's Research Director Paul Brothers will take you through camshaft installation and degreeing techniques.
At Competition Cams, we decided that there needed to be a link between the actual purchase of the cam and the installation into the engine. The best cam in the world and the best engine in the world won't work properly if it's not installed properly. Some of the things we're going to go over today are the actual terms that you'll use in installing your cam, such as base circle, lobe lift, top dead center, and so forth. How to actually install the cam into the engine, checking top dead center on the engine. We'll actually degree the cam. We will check for coil bind on your valve springs to make sure that you don't get in trouble there. We'll show you how to check piston to valve clearance, how to adjust your lifters, and then how to properly break in the cam so it'll do a good job for you. Some of the parts that we're going to use today, you'll actually need dial indicators. There's several different kinds available. Either one of them will do a real good job. No difference really, they'll all work the same. Degree wheels, the same way. There's many different kinds available. Any one of them will do a good job. We've got a spring checker we're going to use in our video. We're going to check our own springs. Most of the time you'll have a machine shop do it, but they'll have this equipment available. The only other thing really that's involved here, we've come up with a harmonic balancer installing tool, which in this case has got a little adapter, which will allow you to install your gear onto your crankshaft. Some of the terminology we're going to use today involves several terms about the cam lobe itself and about exactly the intake centerline method. Here we've drawn just a simulated drawing of the cam lobe. We'll talk about the base circle, which is just the diameter here, or the very bottom part, the heel of the cam. We'll talk about the nose of the cam. We'll also speak a little bit about the opening and closing ramps, which is just where it goes from the heel to the nose. We'll talk about the intake centerline method, which is what we at Competition Cams actually recommend. What we're doing here is locating the center line of the intake lobe of the cam versus top dead center of the engine. Top dead center being the uppermost point of the piston in the bore. Here, Competition Cams has chosen 106 degrees as the optimum intake center line for the 270 Magnum cam. So what we have to do here, like I said, is locate the center line of this intake lobe 106 degrees past top dead center. There's several things to look at. One being, if you change this location, if you actually make it closer to top dead center, you're going to open the valve sooner. You're going to increase your bottom end power and decrease your top end power. If you make this number larger, move it away from top dead center, you're going to open your valve later. You're going to actually increase your top end power, but you're going to sacrifice bottom end power. So those are some of the things that we'll actually be talking about, some of the changes that you can make, some of the things you might expect. Now here, we've used a small block Chevrolet for our demonstration. Everything that you learn today will be exactly the same no matter what type of engine you've got. You can have a Chrysler, a Ford, American Motors, or any other Chevrolet engine, whether it be a V8, a six-cylinder, it's all the same, every one. The theory is what we're talking about, not just the application. First step in installing our cam is to actually remove it from the box, and we're going to compare the cam card to the numbers on the end of the cam. We want to make sure that the cam is actually the cam that we've decided we want to put in the engine. Just generally look over everything and familiarize yourself with all the numbers on the card. Take your camshaft, wash it well. You can use solvent, you can use soap and water, either one. Inspect it, and check the gear, check all the lobes, make sure it wasn't damaged in shipment. Then just insert the cam into the first cam bearing and let it hang there. You take your cam lube that's supplied by Competition Cams, put a small amount on each lobe and on the gear and on the fuel pump lobe. After you've done this, you'll take your fingers and just spread this lube out so that you thoroughly coat all the surfaces. This will actually aid the cam in break-in procedure so that the lubrite is not worn, and it just will keep from having premature cam failure. Now that you've completely lubed everything, you want to take some assembly oil like you'll use on the bearings, put a good amount on each bearing journal. We're ready to slide the cam in. One neat little trick is to just take your upper gear, just stick it on and insert one bolt, and this will actually give you some leverage so that when you put it in, you won't chip or damage anything. And just gently slide the cam in. Like I say, be very careful that you don't get up against any of the cam bearings or the lobes. Once you slide it in, you can feel that it's very free so that we don't have any cam bearing problem. Then remove your upper gear. We're ready to install the timing chain. Now that we've got the cam installed, we're ready to install our timing chain set. Here we've chosen the Competition Cam's 2100 double row timing chain. One thing you'll have to watch for there is there's 3 keyways in the bottom gear. This will allow you to advance or retard your camshaft through changing the bottom gear. We don't really recommend using it simply because it's in crankshaft degrees instead of camshaft degrees, and they don't really relate. But just to explain a little bit about what we've got, you've got a 0 mark on the keyway and a 0 timing mark. You've got a triangular mark which actually advances the cam, and a triangular timing mark, and you've got a rectangular keyway which retards the cam, and a rectangular timing mark. I don't necessarily recommend using these, but if you do, just remember that triangular advances, rectangular retards. What we're going to do to make it a little easier to see is take some liquid paper and mark our 0 or our circular timing mark. Once again, be sure that you put your mark on your timing mark and not on the keyway mark. Then insert it on the circular keyway. Here we've taken a harmonic balancer installer and modified it so that we can pull it on. You've got to be very careful when you're installing these bottom gears, as some of them are made out of powdered metal. And if you use a punch and a hammer, which is perfectly okay, you've got to be sure that you pull them on evenly. If you don't, they'll actually split and break right at the keyway. And you certainly don't want to do that. And when you pull this on, you'll be able to feel when it bottoms out, when it gets right to the bottom. So then we can remove it. We'll be ready to install the rest of the timing chain set. Just as we did with our lower gear, we're going to take our upper timing gear and mark the timing mark so that we'll be able to easily line it up. What I always do at this point is slip the gear over the dowel pin and rotate the cam so that the marks are lined up. Then when we put our chain on it, we shouldn't have to fight it on. Now we'll take the chain and slip it over the sprocket, put it on the bottom, and then it just slips onto the cam. Sometimes you'll have to take a screwdriver or a punch and move the cam a little bit to get it exactly lined up. And install one of the bolts. You'll just want to snug it down and ensure that the cam gear can't come off. Now you want to always check at this time that the cam gear is parallel with the bottom gear. Sometimes it'll cock on the end of the cam and it won't go upright. So make sure that it is on there flush. The last thing to do before we actually degree the cam is just take a straight edge and hold it between the center line of the crankshaft and the center line of the cam. Make sure that the marks are lined up. In here they're perfectly lined up, so we'll know we're ready to go on to the next step. Now that we've installed the cam in our engine, we're ready to move on to the first step of degreeing. The very first thing that you have to do in degreeing your cam is locate top dead center. We'll use this point several times as a reference throughout degreeing the cam. So the first thing we need to do is install our degree wheel on the engine. As we talked before, there's several different types and any of them are fine. Now we're going to put some sort of a pointer on here. There's many different kinds made. You can fabricate it out of a piece of wire or anything, but you should make it as positive and secure a pointer as you can. And as we've done here, we've put it on the outside of our degree wheel so that if we have to move the degree wheel, take it off, and change anything, we won't disturb our pointer. So that's always a good point there. Next thing, you'll need to move your piston down in the bore just a little bit. Either direction is fine. And then what we've done here is taken a piece of metal. Just anything will work just fine. And we have fabricated a piston stop. Just a positive stop will work. Anything with a bolt that'll go down through one of the head bolt holes, and then a stop here to come in contact with a piston. There's many different types available. You can buy them at a speed shop or just about anywhere. They'll work either with the head off, in this case with this type of stop, or there's some made that you can put in the spark plug hole if you're doing it with the head on. Now that we've got this secure, we'll rotate the engine until the piston comes up and actually comes in contact with the stop. When it does, we'll want to turn our degree wheel and just bring it right up to 0 and lock it down. Once you've done that, you'll turn the engine in the other direction, let the piston go all the way to the bottom, come all the way back up, and as you can see here, we've got 62.5 degrees, so we'll want to split that difference, and that point will be true top dead center. So we'll move it to just under 32 degrees. Now we can remove our piston stop, and we'll be prepared at this time to go on into the second step of degreeing the cam. We're prepared at this time to go on to the next step of degreeing our cam, which is actually locating the intake center line to top dead center of the crankshaft. In order to do this, we'll install a solid lifter in the intake lifter bore, which is the second one back, and then install our dial indicator. It's important that the dial indicator be parallel with the travel of the lifter in the bore. If it's not, it'll give you a false reading, and everything we're doing will be incorrect. Check it and make sure it's solid, and it actually goes down and hits a solid point on the lifter. At this point, you'll want to rotate the engine until you find the maximum lift of that lifter. At that point, you can zero in your dial indicator, turn the engine backwards till you go past 50 thousandths. The reason you do this is so that you can always rotate the engine in the same direction to take up for any kind of movement in the timing chain. You rotate it back up to the 50 thousandths and put a mark on your degree wheel. Continue rotating in the direction of rotation. You go up to maximum lift and come back down to exactly 50 thousandths again. If you miss it like we did, go on back and come back again. Now you'll note your second position and mark that. Here we've got a beginning point of 64 degrees and an ending point of 152 degrees. If you'll add these two together and divide by 2, it will give you your intake center line. The way we're going to actually determine our intake center line, we found our point of maximum lift. We went back to our first point of 64. We came all the way through maximum lift to 152. And we'll take the 64, the 152, we'll add them together, gives us 216. If we divide that by 2, gives us 108. Now that we've determined that our cam is in the engine at 108 degrees, what we're going to have to do is advance that cam 2 degrees to achieve the factory setting of 106 degrees intake center line. What we're going to do is turn the engine back to line up the timing marks. Anytime that you're going to remove your timing gear, you should always line up your timing marks as a reference point when you go to reinstall it. Now be very careful at this time not to disturb your pointer, because if you just remove your degree wheel and your pointer doesn't get disturbed, then you can go right back and not have to reset top dead center. So now we're going to remove our degree wheel, and we'll remove our upper gear and drill it to accept an offset bushing to advance the cam. What we do at this point is actually drill out these holes and install an offset bushing in the dowel pin hole. Use a 13/32 drill bit, and Competition Cam supplies us with some offset bushings which will either advance the cam or retard the cam in relation to the dowel pin to achieve the desired setting. Once we get that in there, then we'll go back and reinstall the gear and recheck the degree of the cam to ensure that we have achieved this proper setting. Now that we've drilled our gear, we're ready to install our offset bushing. As you can see here, there's a fat side to this bushing which always goes to the top whenever you're advancing the cam. So what we'll do here is install the bushing in the gear with the fat side to the top, install our chain on the gear, and reinstall this assembly on the engine. After you've snugged down one bolt, we're ready to reinstall the degree wheel. Go back through the whole degreeing process again. As you recall, we rotated the engine in the direction of rotation to the point of maximum lift of the intake lobe. Since we haven't moved our dial indicator, that's still set. So here we'll want to back up past 50 thousandths, come ahead and stop exactly at 50. We notice here that we're at 59 degrees on our degree wheel. So we want to continue rotating, direction of rotation, through maximum lift, back down to 50 thousandths. That gives us 153 degrees. If we take that number, add it to the 59 that we got the first time, gives us 212 degrees total, divided by 2, it's 106 degrees. So we have installed the cam exactly as the factory recommends. Now what we have to do is remove all our degreeing apparatus and then install the cam and get it ready to go ahead and button the engine up. So we'll remove the degree wheel. We can remove the pointer, and then we'll also remove the dial indicator. One thing to remember here is don't forget your solid lifter. Some people have sometimes gotten in trouble and forgotten to remove their solid lifter. So take it out at this point. Competition Cams has supplied us with a cam bolt locking kit. What this will do is ensure that once we install our cam and bend these tabs over, the bolts can never back out. So now we'll have to remove our third bolt from our timing gear, install that with the other two in the plate, put a little drop of Loctite on each bolt. It's just a little added safety. Now we can install the plate assembly onto the cam. We checked in a motor's manual and found that they recommend 20 pounds of torque for these bolts. So we'll set the wrench and torque to this value. Once we've done this, we'll bend over the locking tabs. And at this point, the cam is completely installed, locked in, and we're ready to move on to check piston to valve clearance, valve springs, and some other things in our assembly. Now that we've gone through all the trouble of degreeing in our camshaft, we want to ensure that we get the maximum benefit from our cam and that it lasts the longest time possible. One of the main causes of premature cam failure is actually the installation of the valve springs incorrectly. You can either have coil bind or you can have excessive valve spring pressure, either one of which will cause the cam to fail early. One of the most common errors here is actually in having excessive open pressure. Several things will actually cause that. One being the cylinder heads having too small amount of installed height, or the valve spring can actually be the incorrect spring for that application. Competition Cams has supplied on our spec card here a number of a valve spring that they recommend. You should always check that and purchase those springs to go along with your camshaft in your engine. Now what they have done, they've supplied us with a spring that is an average installed height for the small block Chevrolet. This is not necessarily correct for every single application. You should either check or have your machine shop check the installed height and ensure that it fits in the area that's prescribed on the spring spec card. In our case, our valve spring card calls for 100 pounds of spring pressure at 1.750 installed height. So what we're going to do is put the spring in the spring checker and check the height at this time. We've placed our valve spring in the spring checker, so what we've got to do now is actually check for coil bind. We know on our heads that the installed height is 1.750. So we'll just bring the spring checker down to 1.750 and then go down to where the spring actually coil binds. We can see here that that occurs at about 1.150. So we know that with our gross valve lift of 476, then we've got well over 100 thousandths clearance. The minimum on spring coil bind should be 80 thousandths, so we're well in good shape right there. There is another way to check it with the spring on the head on the motor, is you can roll the engine over to maximum lift, use a feeler gauge between the center coils, and check for clearance in that manner. You should always try and maintain 40 to 50 thousandths clearance between each of those two center coils to ensure that you've got enough spring clearance. The last test that we have to make before we assemble our engine today is to check our piston to valve clearance. Anytime you install a cam with higher lift than the factory specs, you have to make sure that your valves are not going to contact your pistons. If that happens, it's definitely going to result in the failure of the engine. The method we're going to use today is to actually put some modeling clay on the piston, rotate the engine, and check it that way. Always be careful about the type of clay that you use. We're using true modeling clay, which has a good consistency to it, and will hold its shape when you go through the motions. Just install the clay on the piston, on the innermost part of the valve relief. That's the side that the valve actually comes closest to. Then put some oil on there to ensure that it won't stick to the head. Install your head gasket on the block, and then stick the head on. Install a couple of bolts just to ensure that the head won't come off. Now we're going to insert two solid lifters in that cylinder. Once again, as we talked about the compression of the hydraulics before, we got the same problem here. Put your push rods in, stick on your rockers, and adjust them to zero lash. When you get them down close, rotate the engine until the exhaust valve just begins to open. Then we'll set the clearance on the intake valve. Just feel the push rod and zero lash will occur as soon as it quits turning. As soon as you take all the slack out of the system, you'll have zero lash. Pretty easy to feel. Now continue to rotate the engine. Exhaust valve will go all the way open and then close. The intake valve will open and begin to close, and we'll do the same thing with the exhaust. Now we can just rotate the engine 2 complete turns. That'll ensure that we have passed all the points of the valve to the piston. Now we're ready to remove our head and check the thickness of the clay. Make sure when you do that you pull the head straight off. You don't want to damage your clay and give you a false reading. Remove the gasket and rotate the piston to the top of the bore. We're going to use a razor blade, but you can take a pocket knife or anything and cut your clay so that you can come back and check your thickness. Just cut it right down the center. It'll give you a good area to go back and check. Then you can take a caliper and just go in and measure the thickness of the clay. In our case, on the intake valve, we're at 200 thousandths. And on the exhaust, we're at 215. minimum on a small block Chevrolet is 80 thousandths on the intake and 100 thousandths on the exhaust. On a street engine, you really don't want to run them any closer than that. If you advance the cam some, it's actually going to decrease your intake clearance and increase your exhaust. If you retard the cam, it's going to go the other way. It will increase your intake and decrease your exhaust. If it doesn't come up sufficient clearance, you'll have to take your pistons out, take them to a machine shop, have them fly cut, then you can come back and put it together. One of the final things to do in assembling our engine is actually installing the lifters. You should always install new lifters on a new cam. The reason for this is that the old lifters will have the crown worn off and it will not allow the lifter to rotate as it should on the cam. So when you put your lifters in, actually oil the lifters, and as they go in the block, make sure that they slide in easy and there's no interference in the lifter bore. That'll also prevent the lifter from rotating and cause premature failure. Once the lifters are in, you can install your push rods. Once again, it's a good idea to put new push rods in, ensure that the balls are nice and round. We've chosen Competition Cam's Magnum roller tip rockers. What you should do here is install your rockers. They furnished us with some grease. Always lubricate your rocker arms well between the ball and the socket. And install the nuts and we'll be ready to adjust the valves. The way we're going to set our valves is using the preload method on the lifters. We'll just adjust most of the slack out of the valve train, rotate the engine in the direction of rotation, and watch your lifters. As soon as the exhaust begins to open, we can adjust the intake. Just feel the push rod, and when you feel all the lash go out, you'll add another half turn. This correlates to the 20 to 40 thousandths preload in the lifter. Continue to rotate the engine. As the intake valve opens, goes to maximum lift, and begins to close, we'll do the same with the exhaust. Tighten it down until you feel all the clearance out. Give it the other half turn. Once again, meaning the 20 to 40 thousandths clearance. Some engines have non-adjustable rocker arms. What you have to do here, instead of just being able to tighten down the extra half turn, you may have to either shim or shave this rocker arm pedestal to raise or lower the rocker arm on the engine. The only other way to do it is to use an actual adjustable push rod. They're pretty well available everywhere. For a solid lifter camshaft, instead of the 20 to 40 thousandths preload that we talked about, you'll have to just set to the recommended lash. After you've installed and degreed your camshaft, the only thing you'll have left to do before you can actually operate your engine is to do the proper break-in procedure. We've chosen to do ours on a dyno so we can actually check the horsepower of the engine. But if you do it in the car, it'll be exactly the same procedure. One thing that you should consider prior to actually starting the engine is in certain racing or high-performance applications other than the high-energy or Magnum series, these cams require different valve springs. If this is the case, then you should contact your dealer or the Competition Cam's technical staff for more instructions on actual camshaft break-in. Now what we've done here, we've built the engine, we've put 30-weight non-detergent oil in for the break-in, We're going to start the engine, bring it up to 2,000 RPM immediately on startup. We're going to hold this RPM level for 20 to 30 minutes, varying it from 2,000 to 2,500 RPM. What this is going to allow is, as the crankshaft goes around, it's going to splash oil up on the cam and the lifters and help properly lubricate it. You'll find that the first 20 or 30 minutes of the camshaft's life are imperative on how the camshaft's going to live and what kind of service it's going to give you. So now we're ready to actually have some fun. We're going to start our engine, run it on the dyno, and actually tell if everything that we've done worked out for us.